Dear students, in this video we will discuss the derivation of directivity of an element broadside array. We will derive the directivity of broadside array.
So what is the directivity formula? Directivity is equal to 4 pi by sigma. P mere P is equal to 4 pi by sigma A, where directivity of broadside array, n element broadside array. N element, very important one, broadside array. N element broadside array. So D is equal to 4 pi by sigma A, where sigma is beam area. Sigma is beam area. Okay, you know the formula for beam area. What is the formula for the beam area? Beam area sigma A is equal to Pn of sigma. Okay, what is this Pn? Pn is normalized power. Is normalized power. So what is the formula for the normalized power? Normalized, any normalized N is equal to P into P max. This is normalized. Now, here we are not having any power components. Okay. So, what is the relationship between power pattern and field pattern? I have discussed in the first unit. The relationship between power pattern and field pattern is equal to power pattern is equal to field pattern whole square. Field pattern whole square. Okay. So, D sigma means what is the value of D sigma? The value of sigma A is equal to N D sigma normalized power to D sigma. D sigma value of D sigma is equal to sine theta into D theta D phi. So this is the value of D sigma. Okay. So power pattern is equal to field pattern. So here this power pattern I will express in terms of field pattern. Okay. So what is the field pattern? Normalized power of field pattern N of theta is equal to E of theta comma phi by any normalized one. It is divided by its maximum value. Dividing by its maximum value. Okay, so E of theta comma phi by E of theta comma phi maximum. This is nothing but already for an n element array, we have derived this. Okay, so for an n element array, E by Et max, we have derived that we have got this n of theta comma phi is equal to, so E naught into sine n psi by 2 by sine psi by 2. So this is ordinary electrical field. Ordinary E tangential phi. What is the maximum value of this? Okay. So the maximum value of this is already we have derived that. The maximum electrical field Et by E naught is equal to n. So maximum electrical field is equal to n into E naught. Okay, so the maximum value is that is n into E naught. So E naught will get cancelled. Okay, so what is the thing we'll getting? Sine n psi by 2 by n into sine psi by 2. N into sine psi by 2. Therefore, sigma A is equal to integral of general formula is n into sine theta into ordinary formula is d sigma, but power pattern can be written as electrical field whole square. Okay, so this can be written as phi is equal to 0 to 2 pi. Theta is from 0 to pi. In the place of P, I am writing in terms of electrical field constant, that is n square into what is the value of d sigma? It is sine theta into d theta into d phi. Okay, so therefore sigma A is equal to, so double integral of what is the value of En? The value of En is equal to, the value of En is equal to at the value of En sine n psi by 2 by n sine psi by 2 whole square into sine theta into d theta d phi. Okay. So here what is the value of psi? Psi is equal to, for a broadside array. beta d cos theta. Okay. So if d is very small in the separation distance, if d is very small when compared with the length of array, compared with the length of array. So I can write sine psi by 2, okay, is approximately equal to sine psi by 2. Okay, so sine psi by 2 can be made as equal to sine psi by, therefore, sigma a is equal to double integral 0 to 2 pi, 0 to pi sine n psi by 2 pi n psi by 2 whole square into sine theta into d theta d phi. Okay, so here no phi time component is there. I can bring that phi time component is there. So 2 pi into integration of 0 to pi sine n psi by 2 pi n psi by 2 into sine theta into d theta. Okay, so here let z is equal to n psi by 2. So n psi by 2 means n into what is the value of psi? The value of psi is equal to beta d cos theta. Okay, so sine into beta d cos theta by 2. Okay, z is equal to n psi by 2. Okay, so let us substitute I am changing the limits. Okay, I am changing the limits for theta is equal to 0 degrees. For theta is equal to 0 degrees. What is the value of z? Z is equal to n beta 2 by 2. Similarly, for theta is equal to pi r 180 degrees. What is the value of z? Z is equal to minus n beta d by 2. Minus n beta d by 2. Okay. And so the value of z is n beta d by 2. Okay. So the value of z is equal to n beta d cos theta by 2. Okay, so if I differentiate this n beta d minus sine theta into d theta. Okay, so that is n into 2 pi by lambda into d into minus sine theta minus sine theta d theta by 2 get cancelling. Therefore, dz is equal to minus n by d by lambda into sine theta into theta. Okay, so why I am doing this? All this because I am changing the limits. Therefore, sine theta into d theta can be replaced with minus lambda by n pi d minus lambda by n pi d into dz. Okay, so this is the expression. Okay, now I will substitute this here. So in the place of sine theta into d theta, the place of sine theta into d theta, I will replace this and I will replace the limits also. I will. For theta is equal to 0, z is equal to n beta by 2. For theta is equal to 180 degrees, so I am changing the limits. Okay, so I am changing the limits. Therefore, sigma a is equal to 2 pi into integration of what are the limits? N beta d by 2 to minus n beta d by 2 into. So I am substituting n psi by 2 as z. So that by z whole square into, in the place of sine theta d theta, it is replaced with minus lambda by n pi d into dz. Pi will get cancelled. Okay, so if n is very large, n is very large, then n beta d approximately equal to infinity. Therefore, sigma a is equal to 2 lambda by nd 2 lambda by nd minus infinity to infinity sin z by z sin z by here. So minus is there. I can change the limits. I can change the limits from minus infinity to minus infinity to infinity to infinity to infinity. Sin z by z whole square into dz. Okay. So from integral formulas, from integral formulas, integration of minus infinity to infinity sin z by z whole square into dz is equal to pi. Okay, if I substitute this, so sigma a is equal to 2 lambda by nd into pi. Okay, so 2 lambda by nd into pi. So this is the formula for beam area. What is the formula for the directivity? Directivity is equal to 4 pi by sigma a. Okay, so it is 4 pi by 2 lambda pi by n. Pi will get cancelled once because therefore directivity is equal to 2 nt by lambda. So we have already discussed length of the array. Length of array L is equal to nd when n is large. When n is large. Therefore, the expression for directivity of a broadside array. A broadside array of n element is given as 2n by lambda. So